Okay, so welcome to the panel on the war on lag. My name is CCP Veritas, part of Team Gridlock here. I've got the rest of the team and some other guy here to help. Planning to do about 20-30 minutes of presentation, then open it up to questions from y'all. So without further ado, bing. What is lag? One of the biggest things that annoy me when players are talking about lag is they don't say what kind of lag they're talking about. So I'm going to start by not annoying myself and tell you exactly what kind of lag I'm going to be talking about today. In general, lag is when the game becomes unresponsive. And there's many different ways the game can become unresponsive. The first and most obvious is when the client starts to have problems. For instance, if you don't know what you're doing and you leave brackets on, the frames per second, the FPS is going to get very low and your client is laggy. That's very different from when we have server lag, when the server becomes unresponsive. That's when your modules stop cycling, you start getting the error where you can't warp out because your ship's dead, but you're sitting there watching yourself in your ship. That's server lag. And then there's communication lag. When you have a high ping to the server, it takes a long time for data to get there and get back. These are very different types of lag. And today we're talking specifically about server lag. Communication lag, the routing to Tranquility is an issue that the operations team is addressing. I don't know if you guys saw the dev blog, I believe it was yesterday? Yeah, where they're doing some new systems that help reduce the routing problems to TQ. So those of you in East Bumblefuck, you should have much better routes these days, but that's not what we do in Gridlock. More importantly, what I want to talk about is why we're not currently concerned with client lag. And that's more of a philosophical decision than much else. It doesn't make a whole lot of sense to me to optimize your representation of the simulation if the simulation itself is screwed. So we want to spend our time focused on making the simulation of the game, the simulation of the universe, as effective as it can be. And when we're happy with that, then we will switch over to making the overview more responsive, I know another team's working on brackets, so that's going to happen anyway, making that form of lag go away. But right now, the server is in such a state we are focused on that. So what does server lag look like? This is one of my favorite graphs. I love this thing. We bring it up for pretty much every fleet fight there is. The blue line here is on the scale on the left. This is CPU of the server. This is 100%. You see it goes from about nothing all the way straight up and stays there for a very long time. Each tick here is 1 hour, so this is about a 3.5 hour fight. I want to say it was one of the fights in 020 last week, one of those. The more interesting line, of course, is the red line. This is a fairly new metric that we started graphing a couple months back. I've been tracking it since last August. In other ways, this is how delayed your modules are. So we'll see in this particular fight, it goes up very, very fast. This is everybody jumping in and deploying their drones and getting everything set up. So there's not a whole lot of server processing time for anything else. And we start to run very, very behind. That load starts to ease off and we start getting some actual processing going here. For those in the back at the top here, we reach about 1,000 seconds behind, so about 16 minutes. This was kind of laggy. I think this was like a 1,600 player fight, something like that. It was pretty up there. But notably, after that initial load starts clearing, we come down, and we hit this pattern where we start oscillating up and down. And that's where more of the steady state comes in. If we're seeing a line that's going more or less horizontal, we're keeping up with the new load. At that point, we've hit an equilibrium. It's not totally up to date, but it's not getting worse. And then slowly over time, we come down, and eventually have zero latency on this metric. And that's when it's not laggy anymore. So we can see for this fight, it started off pretty awful, and over time got much better as people died, logged off, rage quit, whatever. So what can we do about this load? Obviously, we can take steps to just straight up optimize it out. And that's what we've been spending quite a lot of time in the past 6 to 8 months actually a bit longer than that, doing. We run the profiler, we do some lab tests with a thin client, we find what the server is spending its time doing, then we look at the code and say, okay, line by line we go, justify your existence. Do you actually need to be here? No, okay, piss off. And then move on to the next one. And that sort of nitty-gritty optimization normally doesn't give you a whole lot of gains, but the Eve code is quite old, and we find a whole lot of nuggets in there that are just kind of gnarly, and we kill them. And we've also done some design changes. Most notably, when we were looking at fighter bombers and they were spamming missiles, and missiles were expensive, that's kind of dumb. So we designed away from that. Fighter bombers now have laser type effects. They're kind of missiles designed-wise, but they're lasers as far as the game is concerned. And they perform a whole hell of a lot better now. We're definitely looking to do more of that down the line. We have a designer on the team now who's looking at ways that we can design around the need to have big blobs to get the job done. We had a roundtable on that yesterday. It was interesting. And we'll leave it at that. We got out of the room alive. I'm pleased. The other thing we need to do is be more graceful about how the game handles being overloaded. One of the first problems that got me into this realm of operation here at CCP was looking at why modules became so unresponsive during fleet fights. This was last July. And I did a blog about that, but I'll quickly recap. There was a bug in the module code that when it was hit would cause the thread of execution that makes modules run to stop and let other people go. Now under an unloaded situation, that's no problem because it'll get a turn again real fast and keep up with life. But in a loaded situation, when you allow other threads of execution to go, you might be waiting 5, 10, 60 seconds to go again, and essentially that meant modules got completely starved out of the system. Fixed the bug, then modules got all the time they wanted, and they starved out every other system. So you could shoot your guns, but you couldn't die. Yeah, that's a bit of a problem. We actually had a mass test where I flipped the switch and allowed modules to take as much time as they wanted, and I tried to say something in chat, and it wouldn't go through. Bit of a problem. So, we fixed that. Another thing that we've run into quite a lot is more for the technical guys in the audience, lock behavior. If you have poor lock behavior in a loaded situation and you're trying to grab locks and release locks, again, comes back to every time you yield execution, you pay a very heavy price as far as getting that task done. And so that guy right there found some problems where jumping in was having some very obscene lock behavior. Fixed that, all of a sudden jumping in became a lot easier. I'm not going to say it's perfect, because it's not, but it's much better. And of course, the solution to everything is drink heavily. We're having a pub crawl tonight, please come help. So this is a similar kind of graph that what Atlas showed in the keynote. Same data, different representation. This is from last August to yesterday. The CPU per user on the cluster, cluster-wide. So while we are focused primarily on optimizations that help fleet fights, that has a lot of spillover into the cluster. If we make gun firing better, one would expect mission systems to get cheaper too, not just the fights. So we use this as sort of an indirect metric of how we're doing. And I'm rather happy that we're from 0.11, which the scale doesn't make a whole lot of matter, down to about 0.08 here. About a 25% improvement cluster-wide of CPU performance. That means we can house more systems on more blades, we can have more blades available to be dedicated nodes, and presumably have more people in those nodes. So we had a lot of very easy wins right away. The missile repeat blog from way back when, and a whole bunch of other friendly things about how damage is calculated and so forth. We kind of had to put the brakes on things to allow the incursion expansion to happen. There was some growth here just because more people were logging in. More people means, it's CPU per user, but the load doesn't grow linearly with the number of users. There's a bit of an exponential thing. So our load does go up a bit more when more people log in, but not terribly so. This guy, yeah, I don't like to talk about this too much. Cool ringtone, bro. Get a dance going here. We had a bug in the incursion release where there was a agent that shouldn't have been published that was, and it was causing a whole bunch of log errors, and log errors are expensive, so, a few million of those, but it got fixed, so we're back on the trend. We started going again in late January, and we've been sliding down ever since. This is the missile optimizations right around here. This is the inventory certification here. And we're back on the path, sliding right on down. We got more in the pipe, and we'll keep this trucking. So I wanted to show an example of what ungraceful overloading looks like. So this is a graph again. We have the module lateness here. This is a different fight, I believe, again, in 020. You guys have been giving me awesome data in that system. I love it. This one didn't get nearly as bad in the module department. We only got up to about 5 minutes over, somewhere in there, which is still pretty bloody awful, but not 1,000. But more interesting is the red line. This is the number of outstanding tasklets that were on the server at any given point. And sort of what that corresponds to is player requests coming in off the server that aren't being processed right now. This is the queue of what's waiting to be done. And this curve was fairly normal. We've seen things like this before where it gets up to about 30,000 and kind of levels off there. But then something happened. And I'm not real sure exactly what that is right now. I believe this was the fight I looked at last Thursday. And the number of outstanding tasklets grew to about 150,000. Quite a lot of things. So we came in Monday morning and we're like, all right, we need to figure out what the hell's going on here. And we're pretty sure we have it. We'll be doing more blogs about this. You'll see this graph again. And if we're right, you'll see a fix maybe in about 2 months, somewhere in there. That's kind of about how long it takes for us to get things around. But what this means from a player's perspective is some of the requests that you put in over here got processed about 2.5 hours later over here. So that's a problem, right? Yeah. So, but we believe we know the answer for that, and fairly certain we know how to fix it. So that's a prime example of ungraceful overloading, where one guy's requests might be queuing up and another guys are going fine. So he's shooting his guns, you can't rage, blah, blah, blah. And that brings about the idea of fairness. Whatever we do when we go over 100% CPU, we need to make it as fair as possible. Now, it's kind of an unsolvable situation where we have more load than the server can possibly handle. How can we do this? It's physically impossible. We can't just bolt on another CPU and say, haha, we're good. And so that speaks to we need to be fair in how we degrade, not only per player, in that your requests need to have the same chance of executing as anybody else's, but also between game systems. What I was talking about earlier about if we give modules as much time as they want, nothing else works. We need that sort of fairness as well. And one of the things we're looking at doing on that, and I brought this up in the roundtable yesterday, is looking at slowing down the simulation time when the server load becomes unbearable. So that, the goal is you may be running at a quarter time, but everything is still responsive. That's something not in the 2-month range, but that's something we want to look at sometime in the next year, being able to do. And yeah, I talked about that earlier. So I want to talk a bit about the Skunkworks deployment and what has been going on and what you can expect to continue. We don't often put out changes with releases. We're flying fast. We're trying to get things out as soon as possible, so it's a bit risky. We've got one QA guy here, and he's fucking awesome, but he's one dude. And we're changing some very fundamental things about the Eve code. So we put it out there, usually in a disabled state, make sure the change is good, sitting there idle for a day or two, flip the switch on, watch things very closely, make sure we didn't break anything. There was one time, I think one of my changes to how damage events got sent to the server broke cloaking. That was bad. Noticed that on TQ when I went to go monitor a fight, and I cloaked my Polaris frigate, and everybody was like, "Hi, guy!" I'm like, "What? I'm cloaked. How could you?" Yeah, that was bad. We turned it off right away. But that's the key. We need to be able to hit the kill switch in case anything bad goes on. And in these style of deployments, we can. So we put it out there disabled. We turn the switch. We watch very closely. If anything smells wrong at all, we turn it off and go back to the drawing board, fix it, and put it back out there again. That isolates us from other changes in the release, and it isolates the release from us. But the downside is it limits when we can deploy. If we go back down to here, remember this 2 months right here, we really just couldn't deploy much to TQ because the release was happening and we didn't want to endanger the release. And it didn't help that the entire month of December I had the flu. So fairly quickly here, this is how the deployment of a change generally goes when everything goes right. This is an actual example, the module repeat optimization I did back in August. There was a blog about it and so forth, but I believe that was a Sunday, because why not? Found the problem, a couple days to fix it, about a week before the next mass test got scheduled. So we had the QA guys banging on it for a couple days, and then they couldn't find anything wrong, so we put it up on the mass test. Everything checked out fine. So the following Tuesday, we put it out to Tranquility disabled, and then a week later, it was enabled. Usually, we enable it a day or two after, but there was a lot of other hot fixes and operations changes behind the scenes, so we didn't have a clean window for that for a week. But this is generally how things go. From inception to turn on, usually within a month. Which is pretty exceptional given how much happens on the back end on Eve. I'm very happy with this. But like I say, not everything goes as fast. We can get bumped due to other hotfixes. If we discover an exploit, we want that fixed before we put it in optimization. That's a pretty clear prioritization. And we do have to dance around releases, what I was talking about. Also, obviously, if something goes wrong, we have to kill the switch, and that sets us back a couple stages. We have to go back to QA and back through mass testing. So anytime we find a problem, that's another couple weeks we got to tack on. And for the most part, anytime we have to change the client, like if we change the protocol, the way the server talks to the client, those have to wait more for a real release because we don't like to annoy you guys with having to download a client every week. And that becomes a real problem for people on limited bandwidth connections and so forth. So mass testing. We rely very heavily on mass tests in order to keep this chain rolling. Now, like I said, we put in a change, Daniel beats the crap out of it, and then we ask you guys to beat the crap out of it. It's basically what it comes down to. Because you guys do things that we don't think to do, and so you're going to expose the problems. And we obviously can't do everything in the lab because the lab is very sterile. The thin clients only do exactly what we tell them to do. If they started doing things that we didn't tell them to do, we'd shut them down because we fear for our lives. But yeah, this is basically an employee. Please show up to the mass tests. Without them, we would have more lag because we wouldn't be able to put our fixes out fast enough, and we would be very sad and have to drink more. Yeah. Oh, who am I kidding? We're going to drink more anyway. So this is just an example of the sort of data we get out of mass test. I have no idea which one this was, but this is the standby script that we go on. We have a jump between two systems on the same node here, a jump between two systems on separate nodes here, and then we set up for a gate camp, jump into the gate camp, have that for about 10 minutes or so, tell everybody to stop, and they don't because they're dicks. And then we go bash a pause or spawn some AIs and go kill them or something like that. But this is just one example of the things we get. We get a lot more timing information and so forth. But I just want to go through very quickly what we can see from a graph like this. Right away, it's going to be more evident to the guys up front than the guys in back. But you can see that this graph here, this slice, is much thicker than this one. And that tells us that if you're jumping within the same node on the cluster, that causes more load than jumping out to another one, which is not too much of a surprise. And also that this guy here, we're jumping from this node to this node. This is way bigger than this one, which tells us most of the load involved in jumping is on the node that you're leaving, which is kind of a counterintuitive thing, because you generally get the lag on the receiving end, but that's because the receiving node is already screwed. But in the lab sense, the load on the receiving end is fairly low, which is an interesting result. And then fighting, we really need the more detailed things to say too much, but it's not too surprising that a PvP battle is more intense than a pause bash. But it's good to know. And of course, we have about 20% dicks. So at this point, I'd like to open it up for questions. We've got a mic up here and a couple of guys to help me answer. We've got myself, Veritas. We got CCP Master Plan and CCP CQ, from the cluster team. And then our lovely QA guy whose CCP name I can't freaking pronounce. Habakkuk?
Yeah.
So
Habakkuk.
if you have a question, do you
Come on
want
up
to
and
stand up at the front?
Yep. Because you're live on Eve TV. We want to keep it all in the same place.
It's a more technical question. How about do you go about switching off and on the client changes on the technical sense?
So there's two systems involved. There's the server changes and the client changes. I'll talk about them both. We have a very simple system called prefs. I can do prefs.getValue blah, and it gives me a value. That's stored in an ini file on the server. There's one on the client as well, and that can change at runtime. So usually what we'll do if we've refactored a function but its interfaces are the same, we'll take that function, copy paste it, and work on the new one, give it a slightly different name. And then when we go to call that function, we check that press value. We check, am I doing the new missile system? If so, call the new one. If not, call the old one. And that does induce a little bit of load in that we have to ask that a lot. But hopefully our optimization is such that it's better to have the optimized version and the check. And usually about a month or so after we've turned it on, we'll go in and take that flag out and commit the new change to be the only available system. Now on the client's master plan, do you want to talk about that?
Okay, everyone? Yeah.
Yay.
Clients kind of work in a very similar way, except we don't control your clients because they're on your machine, not ours. So when you log in and you get the progress bars and retrieving bulk data and everything else, one of the things that you pull back is a client version of the same prefs file. And so that way we can toggle code on the clients that we've built in. The downside is that means at some point in the past we've had to patch the client with the new code. So that's why client changes take longer to go through the pipeline than server changes.
I should only question about server side, or I can question about network and the client side.
Hit me.
Okay. First question about client. Why would you compile 64-bit client for huge memory usage? Because many of users I know is using SSD to boost load from hard drive to memory, textures, sounds, etc. Why don't you use huge client memory?
I don't know.
Second
I'm
question.
not going to bullshit an answer. I honestly don't know.
Maybe you don't understand my question.
Rephrase it. Yeah. Yeah. You want to come up to a mic? Okay, so my boss would like to say it's because we don't have all of the middlewares that we use on the client in 64-bit. So the client is still 32-bit because of that. Did I get it right? Yeah. Sweet, I get a paycheck.
Another question is network related.
Okay.
Several time ago, you use AX's European links and links, I think. Now you break all AXs and use just layer 3 network provider. Why? AXs are more faster than layer 1.
Is there someone from Ops in the audience? Anyone? No. Unfortunately, that's the operations team. We're software dudes. I don't know. I assume they have very good reasons.
Hi.
Yep.
There was a graph shown with 100% CPU load. In the sponsor showcase, the guy from IBM said that it's not because of the servers that we got lagged, but more of the software and communications. Is he right? How does it fix to that graph? And was it just finger pointing?
I was not present in that, so I don't know what he said. But from my point of view, that's a lot of CPU load. Now, I can guess what his intent was in that the CPUs we have are quite advanced. We get some really cool shit from IBM and those guys. The software is quite old and not always written with performance in mind. So if he's blaming the software, I agree with him. And that's why we're working on it, because that's what we do. We're software dudes. We're taking a lot of the old stuff and making it run much faster. So if that was his intent, to say the CPUs are awesome and the software sucks, in a lot of ways I have to agree with him.
Okay. For other software like SAP and stuff, there's a concept known as adaptive computing, where you can put together multiple CPUs on just one shard with a kind of middleware. Mm-hmm. Do you have something similar in mind to develop for just have a kind of an abstract layer between the different solar systems and all the stuff that is related to fleet fights?
Sounds like a cluster question.
Yes,
Mr. Cluster?
Is this on? Yeah, all right. So we do have something like that already in place for every solar system. We can't split one solar system, but all of them are split across our different nodes. So one load on one solar system is not going to affect another one unless they share a machine. Splitting up one solar system is complicated. Where we use very heavily Python, which is not multi-threaded. So adding cores or adding machines is a very, very difficult process. At CCP and as well in the Python community at large, I was at PyCon 2 weeks ago. We would love to fix that and make Python easily multi-tribal, but it's just a big, big project.
Okay.
One day maybe,
Okay.
I wish. Yeah.
He's back.
Similar question.
I don't know the answer, dude.
Why don't you use multiple cores on client?
Same reason. A very large bulk of the client code is Python as well, and it just simply wouldn't help. There are Python libraries that allow you to go multi-core, but they have such pathological locking behavior that you may as well have not bothered.
Maybe use C++.
Yeah. Obviously, that's where we're headed with a lot of this optimization work. It's in the back of our heads. We could just pull this over to C. But so far, everything we've looked at, we've been able to optimize it far enough in Python that it's no longer significant. There will come a day where we're like, this is the biggest load, and it's as fast as we can make it in Python, and then we pull it over to C. Maybe we multi-thread it from there. But right now, we're getting such wins native to Python. Why bother?
Python 2.6 or Python 3.1?
2.7, baby.
Why not 3.1?
Why not 3.1? Why 3.1?
It's threaded. It's multi-threaded.
Not any more than 2.7. You still have the GIL. Yeah. Yes. The developer in the audience points out that some features of 3.1 are slower than 2.7. I like a lot of the language constructs in 3, but right now we just can't justify doing that port.
Okay, I have two things. The first thing is, will there be any immediate changes to alpha missile spam? Because alpha missile spam is pretty much known to impact quite heavily the server load through the 300 Drakes bomb missiles. With group guns, it can be quite heavy. So are there any changes to it?
So missile spam is what I spent most of November and December working on. I have an awesome graph from my dev blog, which actually, could you pull that up? It's in the folder. Oh, where'd I put that? Missile repeat per second. Bam. Right. So with that, so this is repeats per second, just to make it very homogeneous. And so we went from 48. Hey, stupid slideshow. Get back there. I'll just push the button whenever it switches. We were able on my not TQ spec blade to go from being able to handle about 48 repeats per second up to 248. I'm happy with that for now. Obviously, with guns being 800 to 1,000, there's a big gap here, as you know. But with what missiles do, there's going to be more expense. They put an object into space, they simulate it over a distance, they do collision. They're a lot more complicated of a construct. This is probably about as far as we're going to take it just with pure software changes. If we need to go further, we're probably going to go into redesigning.
Okay, can we still smart bomb them then?
Yes, you can still smart bomb them today.
Awesome. And also, I would recommend putting. You have fixed the repeat bug that was there by a few, so people started to single repeat and turn out of auto repeat in fleets. And people are still doing this, and people still ungrouping guns, which also has a lot of impact on the server lag.
I call them assholes. Yeah.
Yeah. Would there be a chance to heavily enforce people to really listen to them and bring them the information if they start doing this? And FC call this, and FC call this all the time. I was in so many 300-man fleets where FC all the time called for ungroup all guns, single cycle all guns, which made everything worse. And I spent quite a time in 30-minute lag situations.
Yeah.
So would there be a better possibility to get this message across so people stop doing this?
Yeah, specifically with weapon grouping, I believe Team BFF was doing some work with that? No. Team Pi, yes. They gave us the lovely group all weapons button, so you don't have to go through the lovely fitting interface to group them all. You just press dink, and then they're all grouped up. I'm trying to make it easier to group. We've been monitoring the usage of grouped weapons, keeping a very close eye on that. We know about those people. I hate them vigorously. But I don't know how far we're going to go with that. Most likely, we would end up implementing some form of bonus that you get if you do group. Sort of encourage you with a carrot instead of whacking you with a stick. We'll see how it goes. I mean, we're keeping an eye on that as it goes.
Thanks for the time. Could we go back to the slide that shows the unprocessed requests for the server?
Yeah,
I think
sure.
It's 151,000.
That nasty, just F5 me.
Yeah,
I
I'm
got it.
curious.
This guy.
Is there? So we've all dealt with lag as players. It's not
Yes.
something that's new to Eve. It's not something that'll change probably next year, the year after. Yeah, hopefully Eve will.
We can
continue-
hope. Huh?
Right. Hopefully Eve will continue to grow. We'll continue to have more players.
Yeah.
But I'm curious. Is there a way to? But this lag is a little bit different. Is there a way to prioritize those unprocessed requests? I mean, there's two examples that make an impact for players, and that would be, of course, jumping out. Get me the hell out of here. Getting attacked. I can't do anything.
Right.
And then logging off.
Yes.
Is there a way to bring those to the front of the line?
Prioritization is a touchy subject. Anytime you prioritize a certain task over another task, you open the capability of players being able to starve the other type of task. So if you've got 2,000 people at your disposal, and you know that logouts are prioritized, you have 1,000 of them logging in and logging out constantly, and that denies everybody else the ability to do anything. So I'm very hesitant to do that type of prioritization. Specifically, what we found with this is it's actually some very poor locking behavior. This is a software bug. So I want to get to the point where we see this sort of curve where we have a smaller number of tasks that are evenly delayed. So your warp out may take 30 seconds to process, but so does your locking request, so does your turn on guns request, and make it even. And then as we do more optimizations, the hope is we bring down that time until eventually 0, or we implement the time dilation idea and it remains 0, but the universe is slower. Does that satisfy your question?
It does. I could see certain coalitions using that tactic.
Yes, certain coalitions will do certain things. Certainly.
Yeah, so my question, I'm doing more small fleet warfare, so I don't see like that much. But my question is derived from what I've read, so you can correct me if I'm wrong. But I understand that before, when we had lag, it was more the two sides that was lagging together or more evenly, and now it's more the party that jump in that lag. Is it right?
I don't know. That sort of report would make me think that it's this problem, and I don't fully understand this problem yet to be able to say that one side is favored over the other, but that smells like it.
Yeah.
So if that's true and I'm right, then the fix is coming. If I'm wrong, fuck.
Okay, good.
This is the last question because we're running out of time.
Fair enough.
All right, then I'll be really annoying. With the increased usage of carriers and specifically super carriers in large engagements, is it viable to somehow group drones in a similar fashion as guns, for example, by creating...
The super drone.
No, but a theoretical formation flight of drone with...
6 of one, half dozen of the other, right? On the server, it would be a super drone, and then on the client, it would look like a cool little fleet.
Yeah.
That is absolutely on the table. The players have often told me, drones cause lag. I'd go to the thin client test, put out a couple thousand drones, have them engage, and be like, this is fine. But the problem with drones is launching them and pulling them in. And sort of what we saw back here, it's a big problem. That's code we've touched before, but we didn't go as far as we needed to on optimization, because for what we were doing at the time, it wasn't needed, but now it's needed. So this man right here has been working on that as of like yesterday. So we're going to try to make that event much less impactful. And if we can't, then we have to go to a design solution like the grouping and solving it that way.
I have actually a second part, also having to do with specifically fighters, because they have no graphic representation of what they are actually doing. They only say, "I am fighting," which is about as useful as the newspaper came yesterday. So, and I've been in, well, for an example, in 020, where
my favorite system.
Yes. Where the FC did recommend that all carrier and super carrier pilots regularly re-engage their drones.
He's a dick, okay.
No, but he had very valid reasons for it, because he said that his experience was that would deliver more damage on target than not doing it. So is there... Yeah.
I'll have to test that.
What it probably is when they call and re-engage drones.
You want to talk into the mic, Colin?
What it probably is drones operate on the same tracking formulas as regular guns. So when you recall and re-engage the drones, they're on a straight path towards the target, so their tracking is much easier. but when they start orbiting the target, they actually lose tracking and hit less. That's one of the features of drones.
So you should fix that.
Yeah.
That's our designer, man. Okay, so I believe that wraps up what we're doing here. Obviously, if you guys want to stick around, I'm not going anywhere.